Bismillahirrahmanirrahim. Today we are going to speak about the binomial distribution. So let's define the binomial experiment and how this is different from the other probability experiments. The binomial experiment is a probability experiment that satisfies the following four requirements. Four conditions must be satisfied for the experiment to be classified as binomial experiment. The first one, there is a fixed number of trials. Fixed number of trials, and we will call this N later on. Each trial can have two outcomes, or the outcomes that can be reduced to two outcomes. These outcomes can be considered as either success or failure. We'll come to this one later on. The outcomes of each trial must be independent of one another. The probability of success must remain the same for each trial. These four conditions, if these are satisfied for the experiment, we call it binomial experiment. The word bi, it means two. So it is like we are speaking about two outcomes, either fail or success. So again, we must have fixed number of trials. Each trial can have two outcomes, or the outcomes can be reduced to two outcomes. You can say two categories. The outcomes of each trial must be independent of one another, and the probability of success must remain the same for each trial. For example, selecting 20 university students and recording their major. The question will be, I have 20 students, but what are the outcomes? Because we are recording the majors. So the majors can be math, physics, chemistry, business, mechanical engineering, or electrical engineering, or whatever. So we can see that we have more than two outcomes, and these can't be reduced into two outcomes. So this one is not a binomial experiment because the outcomes are not two and can't be reduced to two outcomes. So this is not a binomial experiment. Selecting 20 students and recording their gender. N equal to 20. Gender, so I have either male or female. So we have 20 students, male or female. So this is two outcomes. And the gender, choosing male or female, it is 50% for each one. If I'm just selecting one student, that will be either male or female. So to get a male, that will be 50%, which will be fixed for each student that will be selected. And also, in choosing each student is independent from the others. So this is yes, because I have two outcomes, male or female, and these are 50% and 50% for in each trial. Each time we are choosing one student, I will have either male or female. So it is 50% for each one. And this will be independent and remaining the same for all the selecting students or selected students. So this is yes. It is a binomial experiment. Recording the number of children in 10 randomly selected families. Recording the number of children. Number of children might be 0, 1, 2, 3, or 4. So it is more than two outcomes, and it can't be put into two categories or two outcomes. So this is not a binomial experiment. This is not a binomial experiment. The outcomes of a binomial experiment and the corresponding properties of these outcomes are called binomial distribution. Before we spoke about the probability distribution. Now, if we have binomial experiment, then the distribution will be binomial distribution. The notation for the binomial experiment is given by capital P of S. This will be the symbol for the probability of success. Probability of success. P of F, the symbol for the probability of failure. Small p, this is the numerical value or the numerical probability of success. And the Q is the numerical probability of failure. So that P of S equal to small p, and P of F or capital P of F is equal to 1 minus P, that will be Q. So we have two outcomes, success or failure. So it is P and 1 minus P, the other value. N or small n is the number of trials, and X will be the number of successes in n trials. See what I mean by this one later on. I'm going to solve one example to explain the meaning of these notations. In a binomial experiment, the probability of exactly X success in any trial is given by P of X equal to n factorial. This notation is called the n factorial. The n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2, and doing this up to n or up to 2 times 1. Just detect 1 in each time, in each step. So it is n times n minus 1 times n minus 2 up to 2 multiplied by 1. Because this is n factorial. So the probability of binomial experiment is given by P of X equal to n factorial divided by n minus x factorial times x factorial multiplied by P to power x. P is the probability of the success times Q to power n minus x. To explain this now, let's have this example. A coin is tossed 3 times. Find the probability of getting exactly 2 heads. See, first of all, is this a binomial experiment or not? If we are tossing a coin has 2 outcomes, head or tail. So this is 2 outcomes. And each time we throw the coin, the probability will not affect the other trials. So this is a binomial experiment. So we have coin. For the coin, either I have head or tail. These are 2 outcomes. Getting a head, P of head is 1 over 2 in each time. So it is remaining fixed in each trial. In each time we are choosing the coin, I will get head or tail, and P of getting a head is 1/2 in each time. For the tail also it is the same, equal to 1 over 2. Now we are choosing the coin 3 times. So we are doing the experiment 3 times. So this is n. N equal to 3. So n is the number of the trials. We are doing this 3 times or 3 attempts. So it is the number of experiments. This is n equal to 3. Now getting exactly 2 hits, this is x. X equal to 2. Now I have n equal to 3, x equal to 2. Now we are speaking about getting hits. So we need to find P of h. P of h is equal to 1/2. This is, because we are speaking about the head, this is B. So small b equal to 1/2. And the Q is 1 minus 5 is 1/2. So P equal to 1/2, it is the probability of success each time. It is the probability of getting success. That will be 1 over 2. Q is equal to 1 over 2 also. Now I need to find the probability of getting exactly 2 hits. So B of 2, x equal to 2, is equal to n factorial. We are now applying this formula. It is 3 factorial divided by 3 minus 2 factorial multiplied by 2 factorial multiplied by 1/2 to power 2 multiplied by q 1/2 to power 3 minus 2. So 3 factorial means 3 multiplied by 2 by 1. This is equal to 3 factorial is 3 multiplied by 2 multiplied by 1. This is the meaning of the factorial. 3 minus 2 is 1 factorial. 1 factorial equal to 1. Multiplied by 2 factorial, it is 2 multiplied by 1. This is the factorial of 2. Multiplied by 1/2 to power 2 is 1 over 4 multiplied by 1 over 2. 3 minus 2 is equal to 1. So it is 1 over 2 to power 1. I can simplify. This is 3 multiplied by 2 is 6 divided by 2 is equal to 3. So it is 3 multiplied by 1 over 4 times 1 over 2 is 1 over 8, which is equal to 3 over 8. So the probability of getting 2 hits is 3 over 8. This is a very easy example, and it can be done using the classical way. That we can list all the outcomes and count how many 2 hits we have in our outcomes. You see that we will have 3 outcomes in the sample space divided by the total number. This is what we did before, but now we are doing this using the binomial distribution. So the P of getting 2 hits equal to 3 divided by 8. Let's have another example. Compute the probability of x axis using the binomial formula. This is already given everything there. We have n, we have x, and we have p, which is 0.42. And I need to find the probability of x. So for this one, first of all, we have to find the q. Q is 1 minus b, which is equal to 1 minus 0.42 equal to 0.58. So it is 0.58. So the probability of now of 0, x equal to 0, is equal to, this should be small n, not small n, equal to n factorial divided by n minus x factorial times x factorial multiplied by b to power x multiplied by q to power n minus x, which is equal to n factorial means 9 factorial divided by 9 minus 0 factorial multiplied by 0 factorial multiplied by p, that will be 0.42 to power x, that is to power 0, multiplied by q, which is 0.58 to power 9 minus 0. Now 9 minus 0 down is equal to 9. So 9 factorial will cancel with this one. And also we have 0 factorial is equal to 1. This is defined as the 0 factorial. The value of the 0 factorial is equal to 1. So this one down equal to 1. Now 0.42 to power 0, this is equal to 1. So the answer for this probability will be equal to 0.58 to power 9. So the probability of getting 0 success in this experiment equal to 0.58 to power 9. In this part, the second part, n equal to 10, x equal to 5, and b equal to 0.37. Again, we need to find the q. Q is equal to 1 minus b, that will be 1 minus 0.37, that will be 0.63. This is the q. So, p of 5 will be 10 factorial, it is n factorial divided by 10 minus 5 factorial multiplied by x, which is 5 factorial, x factorial, divided by p to power, this will be 0.37 to power 5, multiplied by q, which is 0.63 to power 10 minus 5. This will be 10 factorial is given by 10 multiplied by 9 by 8 by 7 by 6 by 5 factorial. It's just to make it easier. Divided by 10 minus 5 is 5 factorial multiplied by 5 factorial. So this will be simplified now. I will cancel this one with this one just to make it easier. Multiplied by p, which is 0.37 to power 5 multiplied by 0.63 to power 5. This can be used or use the calculator to find the value for this probability. So there's no enough space, so I will leave this. So just using the calculator. Now in the next example, 40% of prison inmates were unemployed when they entered prison. If 5 inmates are randomly selected, find this probability. Exactly 3 were unemployed. So first of all, is this a binomial experiment or not? Yes, it is. So because the outcomes are either employed or unemployed, and we have 5 present on present. So we have n equal to 5 in this one, x equal to given 3. Now b, because we are speaking about unemployed, the question say 40% of prison inmates were unemployed. So b equal to 40%, which is 0.4. It's 40%, which is equal to 0.4. This means q will be 0.6. It is 1 minus b. That is 0.6. So b of 3 is equal to n factorial, n equal to 5. So this is 5 factorial divided by 5 minus 3 factorial multiplied by 3 factorial times p is 0.4 to power x to power 3 multiplied by q. Q is 0.6 to power x or n minus x 5. Okay, this is x equal to 3. So 5 minus 3, which is equal to 2. So this is 5 factorial, means 5 multiplied by 4 by 3 by 2 by 1 divided by 5 minus 2 is 2 factorial, which is 2 times 1 multiplied by 3 factorial, it is 3 times 2 times 1 multiplied by 0.4 to power 3 multiplied by 0.6 to power 2. After this, 4 with 2 is 2, so I will have 10 multiplied by 0.4 to power 3 will be 0.064. 0.6 to power 2 is 0.36. So we can calculate this one. I will have that is 10 multiplied by 0.064 multiplied by 0.36, it is 0.2304. 0.2304. So this is the probability of getting exactly 3 of the present inmate were unemployed. Second part now, let's say that at most 4 were unemployed. We see the difference between the first part, which does say exactly 3, so x equal to 3. And this one say at most 4 were unemployed. At most means x, or let's say x can be 0 or x equal to 1, x equal to 2, x equal to 3, and x equal to 4. This is the meaning of the at most. So x will be less than or equal to 4. This is the meaning of at most. And we need to find P of x less than or equal to 4. It means I have to find the probability of x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4, and add all of them. Or I will use the complement. The complement is 1 minus b of 5. We have 5 present inmate. So if we are saying at most 4, so the remaining is will be if all of them 5. So I need to find, or using the complement rule, that will be 1 minus the probability of getting all of them will be unemployed. So P of 5 is equal to 5 factorial divided by 5 minus 5, because this will be x equal to 5, multiplied by 5 factorial, multiplied by 0.4 to power 5, 0.6 to power 5 minus 5 will be 0. So this will cancel this one. Five factorial cancel 5 factorial, and 5 minus 5 is 0. And it will be 0 factorial is equal to 1. This is 1 over 0 factorial, which is equal to 1 multiplied by 0.4 to power 5. 0.6 to power 0 is equal to 1. So the answer is 0.4 to power 5. This is P5. So P of x less than or equal to 4 equal to 1 minus 0.4 to power 5. This will be the answer. P of x less than or equal to 4, or at most 4, equal to 1 minus 0.4 to power 5. This can be found easily by the calculator. Last one, at least 3 were unemployed. At least means 3, 4, 5 are unemployed. So in this case, x will be greater than or equal to 3. So it means x can be 3, or x equal to 4, or x equal to 5. So I need to find the probability of b of x greater than or equal to 3, which means b of 3 plus b of 4 plus b of 5. This is the meaning. So we need to find the probability of getting 3, or also plus b of 4 plus b of 5. This one, we have it before from the first part. B of 5, we have it in from the last one, which is 4.5. We can speak about B of 4 and just find that to evaluate this, because B obviously we found it in the first part was 0.2304. So this is 0.2304 plus, I need to find now B of 4. Plus B of 5 is equal to 0.4 to power 5. Calculating this one, it will be 5 factorial divided by 5 minus 4 is 1 factorial multiplied by 4 factorial times B is 0.4 to power 4 plus 0.6 to power 1. This is the value of B4. Just find it and add it to the two values. 0.4. If we find 0.4 to power 5, plus 0.2304, that will be, if we add these two, I will have 0.2406 plus this one. We need to find the value, and that will be the probability of getting b of x at least, or x is greater than or equal to 3. Just matter of calculator to find the value.